All right, we have some information here. It says this is a report of the number of hours cars are parked in a sample of 225 customers. So what I want to do, I can see this as a discrete probability distribution because my numbers don't have decimals, so just 1, 2, 3, and so on. I can find the probability of each one of these by taking the frequency divided by the total. Now, if you put dollar signs around the total, and I did it by pressing F4, and it'll do it for you automatically, or you can just type it, it'll make it where I can copy this formula and not have to type this every single time. So I hit enter, I get this value, and I'm even going to round this to 3 decimal places. Is that 1, 2, 3, one more? All right, and so now from here, since I typed this formula, I can grab this corner and just copy this straight down, because what it's doing, since I put those dollar signs, it's doing the next one, 38 divided by 225. Then the next one, 50 divided by 225, and so on. You should always add these because all your probabilities should add to 1, just to make sure it does. So that gives me my probability table. And again, this is a discrete probability distribution. Now, to find the mean, and you probably remember finding the mean for descriptive statistics, and you use the average formula, you can't do it the same way in here. So what you have to do is you take each X value, okay, and my X values are my hours, and you multiply it by its probability, and then you add all of those up. So I take my 1 times my probability, so that's this right here, the X sub I. I'm doing the first one. I could do the next one and the next one, or I can do what you just saw me do and copy that straight down, because what's that's doing is taking 2 times that probability, then 3 times that probability, and so on. This little e here means to sum these values. So I did an equal sum. I highlight my values, and I get, and this one I want to round as well. So I get 1.78 for my mean. Now, unfortunately, the standard deviation is not quite as easy. It's this big old formula. So what this says, and I'm going to kind of do it here in steps, is it says to take each X value and then subtract it from the mean, that's X bar, and square it, okay? And then multiply that times its probability. So if I do equal the X value minus my mean, which is that value, and remember, if you want to copy this, which I do, you put the dollar signs, and then shift 6 to get the exponent squared times the probability. Oops, wrong one. The probability, that one. Okay, this is what I used for the mean. And I hit enter, and probably would be a good thing here to say that this value is the mean. All right, so that's the mean. And so now that I've done this formula once and I've absolute referenced this, the mean, I can take this and just drag it straight down. And I'm going to do the same thing, that this is going to be the standard deviation. But notice that you're going to sum all this, but also square root it. So I'm going to equal the square root of this sum. Close, close. So I did equals SQRT for square root. What am I square rooting? The sum of all of these values, and then be sure and you close your parentheses twice, and then I get my standard deviation rounded. All right, and so it might ask me, you know, how long does it take a typical customer? Are they parked? That's the mean. So that's what in the probability distribution we can call expected value. The mean is the expected value, typical what we would expect. I could also find probabilities like what's the probability the time was greater than 6 hours. And to do that, I would just simply sum all of these probabilities that are greater than 6 hours, which would be what, 7 and 8. And that would give me that probability. And then I could do time is less than or equal to 3 hours. And so less than or equal to 3 hours would be 1, 2, and then also 3 because of that equal sign to get that probability as well.